Hello, friends from RubyKaigi Takeout. So my name is Jônatas, and today I'm going to give you a short talk about grabbing Ruby code like a boss. So here is Fast Project. This is my personal project that implements node pattern. And today I'm going to show you how to build these complex node patterns and how to benefit from getting access to these more advanced tools for Ruby. So I am a big fan of grep, Silverlight Searcher or AG, and also RG. We have several tools for building searches, but they are quite hard to get used to them because they have several issues that are more like for generic search. So here I am to give you some example. So for example, let me say I'd like to see how match I have in my library. So I can see that I have several results, and I can also see like comments here. I can see like method calls, method definition, and this becomes very hard to find what you want. So if you use some more advanced ways, you can also use like a minus n I, for example, and then you can have this line number aside. You can have some more details, like if you put like R, you can also have the file name here, but they still do not show you what you want. So for example, if you want to get some more details, you can also try, for example, uh, this AG, like and then like for example, you can get here minus A 3. So AG with no extra data, it will just build something, but you can also put like append some lines. So here you can see a few more details about what you want to search. But it's still hard to grasp this, and also like this is plain code, so you don't have a syntax highlight and so on. And if you try fast, for example, uh, you can you can do like fast match. Sorry, I need to say what kind of node I want from it. So for example, I'd like to get def match. So in this case, you can see here the results are like syntax highlighted, and they are also, let's say, um, showing the entire method code. So this becomes very cool when you want to understand what you have here. So for example, let's say I would like to understand what is the classes behind this small thing. So I can just put this, that means like the parent argument, and this is going to show us all the classes that also contains the match inside. So here is one class. You can see here several other small classes. They are all inner classes inside the library, and they are all defined in the same same code file. So this is a very interesting approach, and now I would like to show how to build this, how you can benefit from it, and how you can just create these powerful searches for your own use. So let's start with this simple idea of what you have when you parse something. So for example, let's say I have here a method match, and this method contains a node, and this have some logic is inside that doesn't matter for now. So Ruby parse here will just show us this small expression. This small expression is what we see as the uh, AST, so the abstract syntax tree representation in strings. So let's dive into this using command line tool. So as I am inside my personal project fast here, I will just use bin/console that will load my library. So I will have access to the fast here. So with this fast, I can have access to methods like AST. So let me just switch to the top again. And here I have a small sample example. So if I try here AST, so you can see that we have this, and this is a class scrollable node. We can also check the ancestors here, for example, and you can see here like it's also a parser AST. So we are using the parser gem for parsing, and we are also boosting the node with a scrollable node. So it allows us to traverse the AST from the children to the parent. Let's get more details about what we have here. So we have two basic methods. One is the type, another is the children. So you can see here like a single children for the most simple node we can have like a small one. So you can see that it only contains the value. So for example, imagine that we can put here like a float, and we will have the same float value. And if you check here, the entire implementation, this is a float. So this is the basics of understanding. So here you can get like a equal 1. So for example, you get a local variable assignment of something that is a float with 1. So for example, if we want to search for some code similar to this, we can also use here toSexp that will return the same what we saw on the previous implementation that was around the uh, Ruby parse. So here you can understand how you can build these expressions, and then you can try it later, and then you can understand more details. Like, it doesn't matter what you want to search, but you need to see this kind of blocks to understand how you are going to interact with them. So I'm going to show a few examples here. So let's get into more easy one. Like this one is an AST. Oops, let's get simple float value to start more easy way. So I can try sorry fast match. So fast match is a function that allow us to just like try to see if my nodes matches with some specific code. And here I can pass the expression. So if I say, for example, float, that's true because float is the type of my node. And for example, if I just dive here into more details here, for example, I can say float, and I can, for example, ignore the value of my float. So that's still true. But for example, let's say I would like to capture this. So I can use this $sign that I can capture the value. And this is very, very good for getting more details. So let's see now if it works with an integer. No, it does not work with integer. But let's say I am trying to capture both integer or float. So I can use these curly braces for such cases. And here we go again. Um, Another detail that is very cool is like you can just add, for example, extra conditions. Like this is like an and condition. So for example, let's say I'm just searching for, um, let's get just one detail, odd, for example. So this is true, right? So if I say here that I would like to capture this, and this is a odd, and this, oops, it says, uh, I just need to use it like this. If I would like to define a method, like for example, let's say I define a method here, odd, that will receive some argument, and then I can check the argument, for example. So I can say like arg.odd. In this case, this is quite peculiar case, but it will also work here. And then we are just mixing, capturing, and also checking the data. And I can even build something extra here. For example, I can just say that this is odd and and should also correspond. So I am mixing the both case. So this is an endless world of possibilities with exclusive cases or intersection of cases, and you can get very advanced on this and also uh, implement these custom methods that can allow you to do anything you want. So this is the very basics here. So I will just dive into some more practical examples that you can benefit from it. So the next thing that we are going to talk here is about um, parser rewriter. So parser rewriter is allowing us to do replacements. So when you want to do some refactoring or try some code, you can also uh, overwrite the code. So when you have a code, you also have a location for your code. So I get another example here, like just a simple constant receiving an integer, right? So this is a two nodes, and then I can get here one special method named location. And this location will give us detail about everything that's happening here. So this is a very simple one. So we see here the identifier, and we also see here the details about all the sizes here. So for example, if I get here operator and I get here source, I can see where is my operator. If I would like to get the entire expression, I can see here with the source, or for example, I can say here children dot first last location expression dot source. So you can see that you can traverse and find these source ranges. And this is our next thing to allow us to understand better how we can use these powerful tools to also override the code. So here you find the code definition, and you can do the same for just small um, small chunks, and you can also use the parser rewrite for it. So I will just jump into another example here that is one named waiter. And the waiter is a very fancy library that is basically waiter. Let me just open this in two sides here. So if you can see, the library is just like a single sleep method. And here we have a very funny waiter spec. So the waiter spec is something, oh, sorry, I need to just check out the library and remove some files that are going to be generated here. So let's switch back. If I just come to the spec waiter spec here, you can see that we have some before here that is just setting seconds for wait, and then waiter waits for the given number of seconds, and it also returns the number of seconds later. So here I have some very fancy override that does not mean nothing, like it's not like really working. And then let's say I have some very weird test here that is overriding the wrong variable. So this is a useless before and after, because here you can still see that we use seconds. So if we just go to this code and we try here bundle exec rspec, you can see that it will run, wait, and pass. And everything is green, looks like fair scenarios and so on. So we have this code. So let's analyze this code here first, and let's see what we can see from the spec waiter spec. So here we have several blocks of code. So you can see a block of Ruby describe our spec, and then we start with this block before. So this is one very nice target we want. And let me copy this. And what else we have here? We also have this block after. So, and now it comes our experiment. So we want to just see how the code would looks with this. So let's start with this small thing here. So we have a block of send new after waiter spec, and you can see that with this fancy library, it's not validating the params, so the parents. So you can also use it without any parents, and it will still compile because we are just traversing. And see that we have this before, we have this after, we have another before here, and another after. So my question is, what if I remove this and try to run the spec? Maybe it works. Maybe this will work as well, but maybe combined they will not work. So my idea here is just to build a small experiment that will try them independently, and then it uh, uh, will will completely remove this. So let's jump into this small experiment file. So here I'm just loading the library, and here we have a small syntax for this, because we can cover like multiple specs. So for example, lookup will look into the spec folder and get all Ruby files from there. You can also see here that I have exactly the same expression that I showed you before, like just targeting before and after blocks. And here becomes the nice code that you need to understand from this perspective of override. So if you see here, it uses exactly the lock, the node location. Location and lock are just like a small alias for each other. And then you have expression here. So I'm getting the code and saying, hey, if you've targeted this block, just try to remove. And then generate a new file for me, and just do execution of this policy. So if bundle exec, the R spec on this new file works, this is a good change. So let's continue changing and combining the changes. So let's see how it works. So I can just try here, experiment, remove before and after. And here we go. We get the first, it's failing because this is the fair before that I need. So the second one, whoa, this it was not needed. It works. The third one works. And here you see the latest combination, 2, 3, and 4. The three together, they also are just dropped in a single shot, and then otherwise it falls back to a strategy to try to combine pairs of them. So, and now you can see here the git diff. So it just moved the spec to the official one. And then you just get this automated, and you can get some examples that maybe they are like not wrong, but maybe they are weak specs. They are not proofing everything there. So this is the first example that I would like to show you, that I was supposed to show you. And now I would like to go to another example that is usage of this edit part. So as you see here on the experiment before and after, you have this edit. And this is using this remove method. So sometimes when you want to refactor code and you are not very clear about how to do this, you can always rely on the Robocop code base, because they have several of these autocorrect methods that are doing exactly this. So let's benefit from from this tool, like, and let's just try here, def autocorrect, and let's see, I have all the files. So you can see all autocorrects from all the copies, and you can see here, for example, let's say space inside block braces. So it just replaces some specific range with the proper space, or it chooses space with pipes and so on. And then you can learn from it. So I'm using this to learn a lot and to also explore new ways of thinking about code. For example, if you think about how comments work in the code, the comments are basically the limbo between the AST nodes, because you have the reference of the nodes, but when you don't have the codes, you have the comments. So it's a very cool thing, and you can benefit from it. And now I would like to just to jump into another small POC that I built here, that is about a law and weak laws. So this was a real case that I was called from some bug from production. And this is a spec that I will show you. So for example, I will also run the spec here, our spec, spec, file spec. So you can see we have a simple example, and if you check this example, this is a usage that is a weak usage. So imagine that I am allowing a file to receive size, and then I return some value. That's okay, that works, but here I need to say with. So I need to say with file name and then end return. So this code should be exactly with, because let's say if this is like a Ruby library, that's okay. But let's say if I implement my own custom classes, I can have these methods that they have a different signature. So for example, if I would like to check here, like for example, file.method size, I can get here parameters, for example, and then you can see the first parameter is required. So I would like to try to find these guys. So uh, I created one small, very easy way to just group your searches and make it easy to reuse them. So this is the fast file. So here you can define shortcuts. And here I'm coming to a more crazy shortcut that is, sorry, node pattern that is about allow. So I am trying to search for some allow that is getting a constant, doesn't matter the name, then it calls to, and then it calls receive, but the next word is not the word with, so it's just end return or something else. And then I'm looking for all these expressions. So I am trying to load the boot if I am in a Rails ecosystem. And then here, for example, I am trying to find it on all specs, and I will try to search for this pattern. If I find the pattern, I will capture the class name and try to get this class name. And then I will get the method from this, and I will consult the parameters and check exactly this, the same example I showed you. If this is required, it means that I need to also pass it in the width, and that's what we want. So if I try here, I can just say fast.width. Oh, sorry, I forgot the complete name here. Width, hello, receive. And then it, tada, it says that the fast file does not include the parameters. So you can find more details here in this official website. You can just see several examples here in the experience. You can get more details about how it works, and in the shortcuts, I am trying to document things that can be useful for other developers as well. So thank you very much for watching. I hope you enjoyed it and I hope you use it as well. So see you around. Bye.